Okay, welcome to Chapter 5, Lesson 5.1, Solving Inequalities by Addition and Subtraction. This will feel very familiar, very similar to what we do with solving equations, and you've probably already done some of this already anyway, like in pre-algebra and Math 2. So nothing too new here for what we'll do today, mostly review. So we're going to solve linear inequalities by using addition and by subtraction. Here we go. You know how to solve a linear equation. This would be a linear equation. X minus 3 equals 7. What do I do? Add 3, right? You undo the subtraction, so it would be x equals 10. Right. Okay, so that is a hard one. But what happens if I change that instead of an equal sign? Now I've got a greater than sign. X minus 3 is greater than 7. What do I do now? Oh no, they changed symbols on me. What do I do, Sean?
You just add the 3 to both sides and say x has to be greater than 10.
Still do the same exact steps. It doesn't change anything about the way that we solve it, just changes the symbols we use when we write our solution. So x has to be a number greater than 10. There are going to be two different things that your assignment asks you to do today. One of them we'll get to on the next slide. But one of them, it will ask you to check your solution. Just on a couple of problems, you're going to have to check your solution. How would I check a solution? If my solution is x is greater than 10, how do I check that, Sean?
On a number line, you'll put dots on there and then make a line going whichever way.
That's if we do a number line, but I didn't ask us to graph it. I asked us to check it. We're going to do a number line here in a minute.
You can replace x with 10 or with any number greater than 10.
Any number greater than 10, I need to choose. So literally any number greater than 10. 11 would work. 50 would work. 500,000 would work. 10 billion would work. I don't care what number you choose. Just choose a number. I'm going to say x equals 20 because 20 is greater than 10. Yes?
Yes.
So then I would put 20 minus 3 is greater than 7. 20 minus 3 is 17. 17 is greater than 7. That checks. That's a good solution. My solution worked. Okay. We also are going to be doing some number lines, and we'll talk about those a little bit more in depth. So x minus 12 is greater than or equal to 8. Go plus 12, plus 12. X is greater than or equal to 20. I think your worksheet that we'll do today provides number lines for you to graph these on. But if you have to draw your own number lines, remember we've done this before in the past. All I want on a number line, I want the number, that would be 20, and then I want the numbers on either side of it. So 21 goes there, 19 goes here. If you're drawing a number line, oops, I only need those 3 numbers. Well, I only need 3 numbers on the number line. And then you're going to have to put some symbols. So what kind of symbol do I put at 20?
A dot, and then, right,
It's a dot with
Ooh, open circle or closed circle?
open because
open
it
because
counts that as well and then going towards the,
You're saying it backwards. If it has the equal sign, it has to be a closed circle. It's filled in because we are including that dot. We're including 20. Okay? And then if x can be equal to 20, we've got that covered because we put a filled in circle. What about greater than 20? What do I do then?
just make a line going towards 21.
I shade that direction. Shade that direction with an arrow pointing that way.
You can't just make a line.
Well, as long as I can see your line. If you put a line that happens to just cover up that, make sure it's dark enough that I can see it or bold enough that I can see it.
Okay.
So it doesn't have to be scribbles, but so for this one, plus 2.9, plus 2.9. So K is less than 7, 1, 6, 16.7?
Yeah.
Okay. K is less than 16.7. So how do we graph that if I want the number that we're graphing on the number line? Just graph by decimals. It's okay. You can do it like this. 16.7, 16.8 here, and 16.6 on this side. If you wanted to do 15, 16, 17 and graph it somewhere in the middle, if you just want to graph whole numbers, that's fine, and then estimate in the middle where it's at. kind of however you want to do it. I still just want 3 numbers on the number line though. So 16.7, what kind of symbol at 16.7? Open circle, because it does not include that number, so it's not filled in. It leaves that space blank because we don't include 16.7. And then which way do I shade?
Left.
Left. Less than is left. K is less than, so I would shade left. Okay. And then this one, m minus 4 is less than or equal to negative 4, so add 4 to both sides. And m, oh, my microphone's dying, sorry. M is less than or equal to 0. So 0, negative 1, positive 1. And I need a closed circle at 0. And then shade to the left. Okay. Same drill for solving by subtraction. Those last 2 slides we were solving by addition. We were adding to solve it. Now we're going to subtract to solve. Same thing. H plus 6 equals 9. Well, we know how to solve that equation. Be H equals 3, right? But if we change that equal sign to an inequality, we still would subtract 6 to solve it. And H is less than 3. And if we want to check that solution, what would I do?
You just put in
Apply any
3
number or apply any number where H is by a number less than 3.
Okay, H needs to be a number less than 3. I like it. Anytime I can choose 0, that is awesome because 0 is a super easy number to use. So 0 is less than 3. So if I say H equals 0, I'm going to test that number because 0 is less than 3. So 0 plus 6 is less than 9. 0 plus 6 is 6, and 6 is less than 9. That checks. So I have a good solution. All right. So a couple of your problems today, you'll need to check your solutions. All right. N plus 7 is greater than or equal to 4, so subtract 7. N is greater than or equal to negative 3. Be sure if you're graphing negatives that you put your numbers in the correct spot. What goes to the right of negative 3? Negative 2. And to the left? Negative 4. Okay. Open or closed circle?
Closed.
Closed circle because it has the equal sign. And then greater than means right. To the right, to the right. Okay. B plus 12 is less than 20, so subtract 12. And B is less than 8, 7, 8, and 9. What symbol at 8?
Open.
Open circle and shade left. Awesome. And this one, V plus 6 is less than or equal to negative 3, so subtract 6. V is less than or equal to negative 9. Negative 9 goes in the middle. Negative 8 goes here. Negative 10 goes here. What symbol?
Close.
Close circle at negative 9 because it includes that number.
Going towards the left.
Less than. And I may have. Okay, we can illustrate this on. We're gonna graph these two as well. So now it's still solving by adding and subtracting. I won't have to do any division, but I want to get all my variables to one side and all my constants to the other. So look for a way to get your variables to one side without leaving anything negative. So do I want to subtract 4h or subtract 3h?
3.
Subtract 3h. That makes most sense. So that would be h plus 2 is less than 7. Don't forget to keep your symbols the same. Just keep the same symbol. Now subtract 2. So h is less than 5. So if we were graphing this one, draw a number line, we'd put 5 in the middle, 6 here, 4 here, open circle at 5, and then shade to the left. Okay. Now which one do I want to do here for my next one? Subtract 5h. Because if I subtract 6h, then I end up with a negative h over here, and I don't want to mess with that. So subtract 5h, and that would be negative 4 is greater than or equal to h plus 2. Subtract 2, subtract 2. So negative 6 is greater than or equal to h. What's different about the way this solution is written than all the other ones we've done?
It's negative.
We had some negative ones.
It's backwards.
It's kind of backwards from all the other ones that we've seen today. And I didn't do that on purpose, where I made all of them backwards, because we have to understand what it means if these are like this one. If I want to turn this around, I want to put the 5 first. How do I write this one so it's the same expression?
You just flip the sign.
You have to flip the sign. It has to be 5 is greater than h, right? So that it's still the same thing. Those two are equivalent, and this is still graphed correctly, but sometimes we get in the habit of thinking, oh, less than, this symbol is less than, so I have to mark it to the left. This symbol says greater than, so I have to go to the right, but that's not correct. If I mark it to the right, I'll be wrong on this one. So I need a closed circle, and this really says h is less than negative 6, right? I can turn that around and write it as h is less than or equal to negative 6. So if your variable comes first, this symbol will point the direction you need to shade. If the variable comes last, then the arrow is actually pointing the wrong way. Does that make sense? I hope I said all that right, other than the word shave. I don't know where that came from. All right, a couple more examples. This one, this little chart here helps you with some phrases so that you know what symbol goes with different phrases. Sometimes that's the hardest part of writing these problems out, is knowing, do I put less than, greater than, or do I include the equal sign? And this helps you with some common phrases that you'll see in these problems. So Philip needs the temperature of his gecko's basking spot to be at least 82 degrees Fahrenheit. Currently, the basking spot is 62.5. So how much warmer does the basking spot need to be? We need to write an inequality. So if it is 62.5, how much do I need to add to it to get it to be at least 82 degrees? So at least, which one do I need to put?
You need to put equal to, greater than or equal to.
Greater than or equal to, which is weird to me. If you say at least, it means more than, right? At least can mean more than. So it's weird that it has the word least in it, but we don't want the less than. We want the more than. So 62.5 plus x is at least 82 degrees. Then we would solve it, minus 62.5, and he needs to raise it at least 19.5 degrees. Okay? Because he could go up, if he raised it 20 degrees, then it would get up to 82.5. Is that okay? Yeah, 82.5 is okay. 81.5 is not. So he needs to get it at least 19.5 degrees warmer. All right? Sandy has $65 to spend at the mall. She bought a t-shirt for $18, a belt for $14. If Sandy wants a pair of jeans, how much can she spend? So if she spent $18 and she added to that $14 more that she spent, how much more can she add for the price of the jeans in order to be less than or equal to $65 because she can't spend more than 65. So whatever this number adds up to has to be less than or equal to 65.
She's
So
good.
18 plus 14 is 32, right? Plus X is less than or equal to 65. Subtract 32. So she can spend up to $33.
Do jeans cost that much?
Yeah.
You can buy jeans for $30. I do it all the time. And I am a fashion guru
Sure.
or something. All right. So there is a 5-1 practice worksheet. I don't have that slide on here for you. See it's blank, but 5-1 practice worksheet. And let me get the recording stopped. Oops.
Upload that.
Where is it?